So I'll just make an official announcement. Hi, everyone. Welcome to our third session. And please let me know if you have any questions. I'll take a look at the text chat as always, or you can feel free to raise your hands. If I could just get a signal that you can hear me, that would be amazing. So somebody could type yes in the text chat or something. Just a sign of life. Thank you. I appreciate it. Okay. Well, I hope these sessions have been useful so far. If there are things you'd like to go over, definitely please let me know. The agenda for today is pretty straightforward. We're going to go over building an R Markdown document. So how many people have created an R Markdown document so far? Okay, great. So what are some of the advantages of putting together a Markdown document? You could rerun your code, Mike says. Yeah, exactly. Publishing. Sharing. Publishing. Thank you, Ricky. Thank you, Benjamin. Presentation. Sure. Great. These are all reasons for creating a special type of format called a .rmd. I'll just type that in the text chat. And oops, I just hear some people's mics on, so I'm just going to mute everybody. All right, there we go. So what we're looking at here, for instance, is a version of a Markdown document, and this is the kind of presentation that I'm going to show you today. I'm just going through it quickly so you can kind of get a sense. But these are the kinds of things we can do in Markdown. So what I could do, right, like just as we just look at this, I can format my text in a certain way. By having like headings, I can have, subheadings or regular text, and I can actually even have inline code and the output of that code. So it's pretty cool that you together, without using comments, which are those pound kind of hashtag looking things, in an R script, we can actually kind of write a document that describes what we're doing. And when we're working, say, with a data set, so we can start with kind of step one, like import our data, and then we can decide what we may want to show in a report or not show. So we have some options there. So what I like to do is kind of demonstrate creating an R Markdown document and some of the different options. And so right here, this is just an R Markdown document with a special output option. Okay, that allows me to publish it as a slide deck. So these are it just turns into an HTML file that I can then open as a slide deck. But I can just as easily turn this into a document, like a web page that I publish. So there's a lot of flexibility with this format in terms of the output. So the output could be a Word document, it could be a PDF, it could be an HTML file, it could be a slide deck. And I've even seen some other kind of cool formats that are possible. Like you could even create your own like PowerPoint, like literally it will turn itself into a PowerPoint, which could be really useful. If you kind of think capstone projects and if you're using R, so imagine being able to kind of show kind of like a snippet of your code and the output and then begin to interpret your results. So that's kind of where we're headed. With these types of presentations of our data and our analysis. I'm going to press the escape button and just go to my R Markdown document that I created that we're going to go over today actually to learn about visualizing data. But you can see that it has like some basic parameters here. And one of those special ones is an output. And so if I choose as an IO slide underscore presentation, there I have, I'm able to, when I press this knit button, it will actually launch as a slide presentation. If I change this to something else, and I do have many different options, I can knit to different formats as well here. So, and I can change this to just kind of a HTML document. So I thought we would start from scratch. And if you just go to your file menu and you say file, new file, and you choose Markdown. And you'll get this nice kind of dialog box where you can kind of put all the basic stuff here. So the title, and why don't we call this something fun? We'll call this Markdown and Graphs. We want our format to be HTML, so we're going to choose that as our format. You can choose, if you're going down that presentation route, the types of presentations you may want. If you have an updated version of RStudio, you'll also get the PowerPoint option here. Shiny is something that we're not going to do, but this is where if you wanted to create kind of an interactive application, we could publish things as a Shiny document. Or if you have a template that you like using, you can certainly do that as well. We're just going to use the basic document type right now. It's good to put your name as the author. And then we can just say OK. And you'll see that it automatically creates a sample Markdown document for you. So Ricky, you asked a question for PDF documents. At times, LaTeX might be like a package that's required to produce those. So if you're getting an error while you're trying to produce PDF documents, you may need to install a certain library or package. The PDF format is really nice. I've been kind of more towards the moving more towards the HTML format, just because you can kind of like publish and share pretty easily. So these are our basic header parameters. Again, by using the file, create new Markdown document, you get all of these kind of already here for you. You don't want to start like editing and removing colons and things because they all make a difference. Okay, so you want to kind of keep the header information the same. Okay, now let's talk about this. Does anybody know what I'm highlighting right here, what this is called? These things in these backticks. This is called an R chunk. And you can create your own R chunk. So let's say I say something like, my first R chunk. Let's create it like below this basic set of options. You would do this by hand by doing 3 backticks and then an open curly brace and a closing curly brace. And then underneath, another 3 backticks. And you see how my window kind of was grayed, turned all gray, and then now I only, in between the R chunks on lines 13 and 15, you can see that I have my first R chunk. Okay, what's an R chunk? Well, it is a place where you put your R code or your Python code or any kind of code you want in your Markdown document. But we're just going to use R, and then we'll just keep it really simple, and we can just do something like type some R commands, and then we press this button run, and then we can see the output. Okay, right in line here. Okay, so that's kind of like the interaction between an R chunk and executing the R chunk. Then you could also just press the X here if you want to kind of clear that output. Okay, so when you're creating your Markdown document, you want to start with the way that I showed you, just so you get the right format. And then you want to keep this line here, this R setup. This could be called anything. This word is just a way to label your R chunk. You'll notice this label is associated with what you see here, chunk 1 setup. And you notice chunk 2 doesn't have a name. So let's say if I wanted to name that chunk, I can simply say R chunk demo. Okay, so now I have a name for that. So now I have a little bit of a navigation to my R Markdown. Make sense so far? So I just pressed the save button. So I'm going to go ahead and save my R chunk. Not my R chunk, excuse me, my R Markdown file. So I'll say Markdown graphs. So hopefully you're following along. Let me know if you have questions. When you use the hashtag sign here, you don't have to use that anytime you write text. That's going to be the header, okay? So you can have something like my first R chunk, and then have some text underneath demonstrating how to create a simple R chunk with echo equals true, okay? So echo equals true, what does that mean? What do I, when I have this comment here, what am I saying? So if I said something in the R chunk and I said echo equals false, what would happen is that the code would not be the output would not be shown. Okay, so the default is that it's going to be shown. The output here is shown, but when I knit it, it won't be shown. Yes, so echo equals true. Good. We want to show the code. We want to show our nice text that we're writing here with our big headers. And so right now I'm just going to stop. Excuse me, I had a cough for a second, which is one reason why I stopped. But another reason is to kind of show you, after you kind of build out your program, what the final output will be will be shown when you use this button here called knit. So if you press, you could say knit, and it says knit to HTML, PDF, or Word. I'm gonna choose HTML. If you click here, so let me know if you can see that. Okay, so exactly all the information I put, demonstrating how a simple R chunk with echo equals true, right? So I'm getting the input and then the output here, okay? And now this is all the other information that was included in the kind of template that was provided to us. Notice that the first R chunk wasn't shown, okay? So let's go back and kind of like finish out some of the other aspects of this. Okay, so do you see how it says include equals false? So this is a parameter that you can put in if you don't want something to show up, okay? And you'd say include equals false. Okay, and even when I run it, you won't see anything show. Okay, so we'll go ahead and omit that. Now, this is all the kind of sample from lines 18 onward, all the sample markdown information that was given. So it's describing what markdown is, how you can use it, which is fine. I already kind of demonstrated when we click on the knit button. And so I'm going to get rid of all this text here, and we're going to be working with a sample data set. And so I'm going to say that my next header, which I could use the double pound sign, can say something like calculating summary statistics on the CARS data set. And here I can test that out, and I can see that I'm seeing that information here. And that R chunk was already created for us here. If I wanted to, let's say, not have to use the 3 backticks, open, close the curly braces, and then this to kind of create my R chunk, I I could simply instead say insert R. And that gives me a nice R chunk. Okay? So you could have something that says eval equals false. So that's if I do my 3 plus 2 or something, and the evaluation when published won't be shown. Okay, so if I knit that, I can kind of show you. So it just gives me my 3 plus 2 down here, but no output. Okay, so it shows the code, but no output. There might be a reason for that you want to do that. So this is, we gotta go back and revise our comment up here with echo equals true and eval equals true as default. That's what we're doing here in this line 14. Any questions on this? So and now we know what include equals false means, right? It means that we're going to run this. Eval equals true, because that's as a default, but we're not going to include the code to be published. Okay. What's also nice is that we can create plots, which we're going to work on. So we're just plotting something from the basic pressure data set, which just has 2 variables. And we're not going to print out the code, echo equals false. We're not going to print out the code to plot, but we're going to show the output. Okay, and so here's our very simple plot. Okay, so this is not the best example of a plot for a few reasons, because if we just go to the the console window real quick, there are some things that are not explicit in this code, and when we kind of learn new functions and other things, I like to kind of be explicit. But like, so if we just like type in pressure, this is our pressure data set, right? There's all 2 variables. So when I say plot pressure, I'm basically saying plot temperature and pressure. And so a different way to do this, and I'll do it here, right underneath, so you can kind of see the difference, is to say something like comma, oops. Okay, so I have X and Y. Does that make sense? So this is kind of just a shortcut way of doing that. Okay, same thing. If you didn't want the problem is that now you have variable names that are named this. And so we have to start kind of refining how we actually plot and label our axes and other things like that. So we'll talk about that. But when we use the plot function, which comes from the graphic package, which is a package that's included in R, we don't have to install it. We're usually creating a scatter plot. And when we create a scatter plot, we need an X and a Y. So I don't like that example that they show here, because they just say plot pressure, and you probably never even looked at that data set. You're just assuming it worked. So I'd like to kind of just break that down for you. Hope that was helpful. So I would just and this data set's something that's just installed in your version of R, the pressure data set. And we're going to make our charts look way better than this. I think these charts kind of look like, they're from like the 80s, right? So there are many more sophisticated ways that we can kind of try to create charts that are readable and interpretable, and also don't look like they were created on like an ancient computer. We have really sophisticated graphics drivers now, and we can do a lot more with the presentation of information. Okay, and then I'm just going to get rid of this last piece of text. It says, note that echo false was a parameter added to the code to prevent the printing of the R code that generated the plot, right? So we saw that, right? We saw that echo equals false. And again, we can get rid of this word pressure here, and maybe we can say something like, uh, uh, you know, show plot or something. We'll name it like, again, these are just kind of placeholders here for naming your charts. And anything in bold is what you put in the single or the double hashtag. You could also use a single hashtag if you want. Say something like scatter plot, and then you can see how that fits within your navigation. So you have including plots, and then you have scatter plot. So also bold that. Which with it probably decides in the order of the variables in your data set. Edzai is asking a really good question, and I think I'm interpreting it right. Like, how does R decide when I just say plot pressure, what's going to be an X and what's going to be Y? And I'm going to go to the console window here, and I'm assuming it just picked, temperature to be X and pressure to be Y. It just went in order. X always precedes Y, even in the alphabet. So you could just think of it that way. Any questions about Markdown? So now on, the expectation is that you're going to be writing everything as a Markdown document, right? So we graduated from using the console window and using R as a typewriter / calculator to writing .R programs, so writing R scripts, which did not have visual elements included or nicely formatted text, and weren't meant to be any kind of professional document. And now we're entering the professional world of business analytics and working with data in R. And we do that using primarily Markdown documents that can be converted to many different forms. So we will, from now on, really work in Markdown documents. And so even in class, like, you could just expect that that's how we'll be coding. And the nice thing is that you can still code kind of like one line at a time, right? So you can write your R chunk, and then you can run it, make sure it works, and then kind of move on. Cool. So any other questions on this, on Markdown? Because we're going to move on to a new topic. Sure. Edzai, what your question is, how does R decide? So I think I answered that. So R just does it in the order in which it needs its parameters. And you're making a great point, right? So like, is this really how we want to view the data? Right. So this is kind of like what R is doing behind the scenes when it just says, plot pressure. Right. It's not smart. And so if you wanted to obviously reverse this, you would put in pressure and, temperature. And you can see that regraphed. So we're looking at obviously high pressure, high temperatures, low pressure, a lot of You see there's a point in which when the pressure reaches a certain threshold based on our data here, what's happening. Okay. So why don't we go ahead and go to the next topic, which is going to be all about graphing. And I thought I'd do this as a fun markdown document that I've exported to a presentation. And we'll go ahead and just start with some basic graphing techniques. I want to draw your attention to the Materials tab here. We're going to work on using this data that's called CEO salaries. So if you can go ahead and click on that, if you click on that, that should automatically download a document for you called CEO_salaries.csv. Please do not open this in Excel. Okay, just take the file, move it to your working directory in R. And then we'll go back to the document that I showed. Anybody have any questions of what I'm talking about when I say CEO salaries? So you have a Materials tab and go to Training Control Panel. Do you see that? This is where I've been posting the materials for all the sessions. Everybody got it? Okay. Great. Okay, so we're just going to work with this data so you can kind of follow along. I'm going to give a demonstration of some, and so how I'd like you to follow along is obviously start by creating an R Markdown document, and we'll go from there. Make sure your R Markdown document and your data are stored in the same directory. That's going to be important. And that directory is your working directory. And so these are a few things that we went over during the last live session. Would anybody like me to demonstrate what I mean by that? Okay, so there's a relationship when you're writing your code about where your files kind of live. So one of the things I'm gonna ask you to do is create an R Markdown chunk that looks like this. Okay, and there's a few things here, right? Like I'm using the read_CSV function, and I'm referencing my CEO salaries here, right? So I'm doing this, and the assumption is that lecture_5_lecture.rmd and CEO salaries live in the same working directory, right? Because I don't have a path here. I'm just using a relative path. And so you want to make sure that on your desktop or wherever you have a single folder that is, and that's where you keep your .rmd files, all your files for this course, and your data. So I'm assuming everybody knows how to make a file directory on your computer. Just go to like your desktop or something and name it. And I think one of the exercises where I said like name it my data or something. So you create a file folder somewhere on your desktop, on your computer, and then you make sure that everything that you're working on is stored in that folder. And so that CEO data set, like move it there. When you create your first markdown, save file, save as, and it should, try to navigate to wherever that directory is to save it. Once you kind of have that, everything saved in the right place, then you want to make sure that R knows what your working directory is. And that's where you can go to Session, Set Working Directory. And you choose that file folder where everything is to be your working directory. Okay, and so in my case, I'm going to choose, I think R presentations as my working directory. Oops, no, I'm not going to choose that. I'm going to choose R fundamentals. I think that's where I have everything stored. Okay, and then I'm going to say open. And then that's my working directory. And you'll notice down at the bottom, it says set working directory in the console window. It actually gives me the code for that. So what I do is I'll usually take this code here and I include that in my, I'll probably include that in my markdown somewhere. So I'll say so I'll do another R chunk, for instance, and I'll say set working directory, because then I know that this file is associated with this working directory, so I'm never kind of confused where things live. And then you'll say something like include, because you don't want to include this in the output. No one cares where you store your files. Okay? Any other questions on this piece? Okay. So if you, and I call this like setting up your world. So if you have your world set up, let's move on. And so I'm going to move on to where I was here. And we're going to work on some graphing. So just some basic information on the visualization of data. Typically, this goes hand in hand with showing measures of central tendency, right? We want to see the distribution of data, maybe the maximum value, maybe the minimum value, maybe the median. And we can easily do this with some simple functions for graphing. There's cases where you'll notice that the effect of outliers, for instance, may not be so apparent when we're looking at some measures of central tendency, and it may be necessary to actually visually see those outliers to better understand our data. The types of graphs that we'll create range from histograms to really like scatter plot matrices and parallel coordinates and really fancy types of plots. Today we'll stick to just a few that I have listed here, and I'll describe those, and we'll build them, and we'll use a few different graphing tools to build them, so you have some exposure to the basics, which is really important. A lot of times I know everybody wants to use the latest and greatest packages for doing this or that. And I always think it's great to know how to do things really, really simply, and then be able to build there and note the differences between like graphing using the plot function versus graphing using, the ggplot2 package. And we'll learn both. And we'll also learn some other packages that help with the formatting of our data for output as well. Questions on this? Great. So I hope the next hour will be kind of fun as we kind of go along together. So we'll begin with the basic or built-in functions from the graphics package. So, and we're going to be working with this CEO data set. And so this is what I like us to work on. Few things with my code here. You're going to import your CEO underscore salaries.csv file. You're going to do that using the read underscore CSV function. And that comes from a library called readr. This is a little shortcut that you might not have seen before, but I like to kind of, instead of saying, I'm going to write in the text chat, library readr, which is step 1, and then say read underscore CSV, blah, blah, blah. You can simply do a shortcut and just say read r double colon read underscore CSV, like so in the text chat. So if you ever see the double colon, that's what it means. It basically means package function or library function is how you can kind of read it or say it. Decide if you want to use the shortcut or not. Just want you to know what you're doing when you do that. So in this case, we are going to read in the CEO's salaries data using this function, which we know we'll read it in as what kind of data structure? Anybody remember? Like a simple data frame, right? Called a tibble. Yeah, a tibble data frame, it's called. T-I-B-B-L-E. Okay, and so that's what we want to be able to read in our data as. And down here I had the answer. Look, when I use the head function, that shows me a preview of the first 3 rows of data. I like to do that just to kind of preview the data, see how the information is brought in. You'll see that age is an integer and so is salary. Okay. Questions on this part? So is everybody done with just kind of reading in their data? Okay, so then I will assume you are, and we will move on. Next, we're going to go ahead and draw a histogram of the salaries for the CEOs. And to do this, we're going to use a function called HIST, H-I-S-T, which comes from the graphics package. And this is a univariate visualization. So this means that there is only one variable that we're going to graph. Okay. And we're going to use a few parameters. One is called main, which I'm mousing over here. Here we go. I got a highlight there, main, and that's a parameter. And main is going to be the title we give our chart. So we're going to say something like main equals, you know, my title. And I just typed that in the text chat just so you can see what I mean. And XLab is the label that we give the x-axis. Do you remember when we were working with the pressure data set and the labels didn't look that nice? Especially when I redid the chart to literally pass in the parameters X and Y, right? I had, pressure, $pressure, which was the name of one of the labels. So we're going to use XLab, and we're going to say, my x-axis here. So we'll go ahead and build that. So you notice that I just used the word salary here. And so there's something in my code you're not seeing. I actually used the attach function, and I said salary, and I said CEO, like that. That allows me to say to R, hey, I'm working with the CEO data set, and I'm just going to reference the variables of anytime I reference. I don't have to say CEO $salary in this case. Okay, so there's code here that you can't see. Any questions? Alrighty. So again, we're using the HIST function. It will produce something that looks like this. And we could have just said HIST salary, and that was it, and it would look a lot different, right? So anytime we're plotting a data graphic, we want to make sure that we're labeling things in an appropriate way, and salary bins in USD, and this is probably in thousands, right? So this label could even be improved a little bit. I don't think we're looking at the annual salary for CEO, the max value being between 1,000 and 1,200. And so what a histogram shows us, right, is the number of CEOs, the number of observations that have a salary between, let's say 1 or 0 and 199. And we're looking, close to like, say, 6 or 7 versus, and so then the second one is showing us those CEOs that have a salary between 200 and 399. And we can see that's like in excess of 30. Okay, so it's just a univariate and it shows us kind of like the shape of the data in terms of the frequencies, right? Great. Very, very useful for interpretation and understanding, especially for folks that kind of prefer understanding like the, an entire column of your data. It's very useful. Okay, so this is just a change where I kind of said, salary bins in thousands of USD, a little bit better. And you can see that I just have a note here about the different ranges that the bins represent. I mean, the salary is, Ed Zaya is asking about the data type for salary, which was just brought in by default as an integer because the numbers in our data set are integers. And that doesn't affect here the display. We would still have what we call bins, okay, for a histogram. Whether the data is continuous or not. Okay. And just because it's integer doesn't mean it's not recognizing the salary object, right? And so, Ricky, did you catch my point where I said you need to say attach CEO? You need to say that first. Or you need to say CEO $ salary as your parameter. Good. Okay, so why don't you go ahead and do one for age? And see how that looks different as well. So now you're creating 2. I'll give you a second to do that. And make sure you don't just say hist age, right? That you actually put in the parameters, the main and the XLab. Hi, I'm going to assume that everybody's has done the second one. So let's go ahead and move on to a different visualization type called a box plot. And so a box and whiskers plot provides depiction of the median, interquartile range, the range of the data. And so we'll look at an example of this. But what we care about is noting the spacing between different parts of the box to help show the spread and skewness of the data. And so we can produce one of these. Again, it's a univariate display. using the box plot function. Okay, just like we use the hist function, here we use a box plot function. We pass in x. X is going to be either salary, right, or age. And then we're going to enter a title using the main parameter. And then we're going to use something called frame.plot equals false. So I'm adding a new parameter that I want you to kind of learn about, which is getting rid of the box around the chart, which just doesn't really add any information about the data. It's decorative and kind of distracting. So we'll go ahead and do that. And there's many other parameters where you can change the orientation and lots of good stuff. Add color, and we'll get there. But let's begin with having a great title and showing our data visually. So here I'm passing in salary. Remember that I am using the attach function, so I don't have to actually say CEO $ salary. And this box plot function, remember, comes from the graphics package, so I don't have to reference any libraries. Here's where I put my title, and all these parameters are separated by commas. And this is a parameter that's a Boolean or logical parameter where I'm saying frame.plot equals false. The default is true. So that's why I usually have to, when you have to include a parameter, that's a logical one in these types of functions, it means that the default is true. Any questions on the box plot? So I want to know who this, who this CEO is. I want to be that one. Okay. Very funny. The ex-wife, yes. Oh, that was quite a day. Okay. So go ahead and create another box plot for age to show the median age and age range for the CEOs in our data set. Okay, so I'm going to assume that everybody's done that. Let's go ahead and move on to the next step, which is creating a scatter plot. So if you want to maybe say, does salary increase with age, or something like that. So you can build a scatter plot. And here we can go ahead and look at the usage for scatter plot. Now, we already saw this before with the pressure example, right? We're using the plot function. We're passing in a parameter, but really two parameters here. There should be an X and a Y here. That's a little typo I have. Okay. And then we have our main here, XLab. You have your Y lab if you have a Y label. And I'm going to set the frame plot to false. Okay. And so here's the real example. If you want to go ahead and plot that. You notice I still have the X, the Y label here for you to kind of fix. Oh my gosh, I'm sorry. I was like going on this whole so good. Like great questions are coming up. This is what I want you to be thinking about. It's not just about being able to plot. We want to make sure we're plotting the right things, right? So we want to think about what we're plotting on our x-axis versus our y-axis. Can everybody hear me? So go ahead and replot this with the inverse variables. Okay, thank you. I'm glad you can hear me. Okay, so now you'll have some fluency with not just understanding where x and y goes, right? But now we're going to look at particularly the dependent variable, right? And so what we want to see as a dependent variable in this case obviously is salary, not age, right? So you want to flip these. If this is our question here that we care about, right? So making sure that and just in the same examples, I mean, when we were looking at box plots and histograms, those, tend to be like, much more descriptive. But now here we're looking to see if there's a relationship. And obviously we could run the core function and to see if there is a relationship as well. But we can visually begin to plot that. Good. So as we kind of move on to the we can move on to more kind of sophisticated graphing packages, and we're going to do that after we do another exercise. But I want to make sure you go ahead and I'm going to go to my markdown and also regraph what I've asked you to regraph too as well. And the nice thing is once you have kind of a template for graphs in your markdown, you can do some interesting things. So let me just go to my template. So here I'm able to kind of do a few things in my R chunk. So we can do something that looks like this. So we can set in our R chunk here our figure height and our figure width. So we can use more of the screen to kind of show what we're working on. And we can also align our figure to say the center. Okay, so these are just like some extra parameters you can show so we can kind of see the difference. I didn't use the attach function here. So you can kind of see, and now we have to go ahead, you still have to go ahead and label that X label, which we're going to call salary. And we have to rename this one. And so you might get something that looks like this, and then if you get something, and you could always like use this button here to make your charts look bigger. So if you want to kind of look at them bigger. And again, this is just the basic plot function here. So now I like to kind of move out of the salary example and go to another example, just so you can work through exercise 5.2 using some of the basic plotting. As well. And so I'm just going to kind of review what's ahead for 5.2 is that you're going to be working with a few different data sets. So you're going to be producing plots that describe the GDP and life expectancy during 2016. And so you'll need to create a new column, a new data frame with these two columns to kind of achieve this task. And then we're going to, we'll do GDP and life expectancy as a scatter plot. And then we'll create a histogram of the GDP. And so these are using the basic functions, and then a box and whiskers plot. And so that's something we can work on now. So why don't you go ahead and just practice these three with a new data set. Again, this is available in the materials tab on exercise 5.2. So we'll do something a little different this time. I'm going to give you 10 minutes to work on this problem. And so it's my time, it's 10:28. So it'll be 10:38 by the time we come back, and we can do that and we can review it. And I'll ask you to kind of participate and put your code in the chat box to kind of share it. Okay? So I'm just going to set a timer for 10 minutes, and you can go ahead and work on this. Okay, just want to check in and see if everybody's done. Just give me a yes or no if you've been able to complete the exercise. Thank you, Philip and Nabha. Thank you. Does anybody need more time? Benjamin, is that a more time or is that you're done? Because now I've asked a different question. Why don't I give everyone just another 2 minutes and then we'll resume. I'll just set the timers, make sure that we choose 2 minutes. Okay, I hope the extra 2 minutes was helpful. I'm going to go ahead and share my screen. And what I like to do is really get your, your code, and I want you to share your work in terms of what you've done in terms of answering these questions. So the first one is just setting up the problem. We're looking at 2 different data sets. And so I'll show you kind of step 1, right? So step 1 is we've set up our R Markdown document. You make it look all pretty like this, right? So you have your title, author, output, everything that kind of comes default. You want to make sure that we're going to we're using the knitr library here, and we're setting all of the chunks to read echo true. So we're going to read those out by default. So we don't have to go ahead and globally set each one. And the first step is we're going to import our data. Now this is very straightforward. We've been doing this 9-10 times already, so nothing really to go over here, except just want to introduce that I'm calling the GDP dataset GDP and the life expectancy dataset LE in my example here. So when we read those in, wonderful. And then the next step is to go ahead and format the data if you want to. That's something that I did. I don't know if anybody else kind of went ahead and formatted the data before they started plotting it. So that was something I did. So I went ahead and I extracted the country name column from the GDP data set, and I assigned that to a variable called country. So this is now basically a vector that contains all the country information by country name. I extracted the column name 2016, and remember, because I'm using a Tibble, I can use there's double quotes around numbers or backticks. You could use either. And you know, I'm going to go ahead and uh, 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 divide this number, the GDP 2016. So, and then I'm going to go ahead and assign that to 2006 GDP 2016 as my variable, and then of course life expectancy. So now I've extracted my three vectors, which is really the point here. And now I'm going to bring them together into a data frame. And this is where we could just use the data frame function, passing in country, GDP, and LE, life expectancy. Now you didn't have to do it this way, right? You could have just worked with the actual columns from each data set if you wanted to. But some of the, it says you will need to create a new data frame with these columns. I just think that's just be easier. And when we use other graphing packages, it's going to be a lot easier if you have all of your, you know, if you're trying to pull X from somewhere and Y from somewhere, you want to kind of make sure that they're in the same data structure if possible. Okay, and so then I'm going to call this GDP underscore LE, like GDP life expectancy. So that's the name of my data frame. So why don't we share about the first part? So create a scatter plot of GDP to life expectancy. Does anybody want to share their code in the text chat? Great. So you might have gotten something, you know, at a minimum, something like this. Pretty ugly looking. I like, Mike, that you said frame plot equals false. And then you could also go ahead and refine your scatter plot, kind of like I did here. So what I've done is just a few things, but looking a little bit better, right? So I have like a nice title. My axes are labeled. I even added color. And so these are things that you can do if you want to just, and I've also set a max value for my x-axis, because I was kind of annoyed that it got cut off here. Like, what about this country? Right? And so the labeling I wasn't really happy about by just the default one. So go ahead and refining that to, now obviously you're passing in our X variable or Y variable. We have a nice X lab or an X label, a nice Y label, a nice title using the main. Okay. And then I'm saying frame plot equals false, kind of how Mike did. And then I could say color, and you could choose any color here. So you can go ahead and add a color parameter to your scatter plot, COL. And this is that modern cyan that I use for everything. So this is the hex code for that. So you can go ahead and choose a different hex code. You know, you could choose, like, if you wanted gray, you can choose, you know, the pound sign plus 6 uppercase C's would be gray. or pound 999. You could also type in, I think you could say something like red if you wanted to. Usually when you're kind of putting in the, you can say red, I'm pretty sure. And then I can get red if you want. Avoid the use of red as much as possible. But you can see how that, you could change the color there. Good. Any questions on this? Okay, so create a histogram of the GDP for 2016. Can I share your code if you have it? So Mike, I was intrigued at this dark magenta. Let's let's see. I'm gonna graph yours kind of live, just using my variable here. Okay, so let's just start from first part. All right, pass that in. I'll get a main. You put a title in. All right. Change that up. All right. Good. And then I would say, like, so when I graph this, what I don't like to see is this at the bottom. So I always like to, the next couple, I like to just use your examples because then we could see what's missing, right? So like you'd want to make sure this label is labeled appropriately. All right, let's keep going. These look good. So we can even just say, do we do this in trillions? I forget. Okay. So you can at least have some more information there. Great. Nice work, everyone. All right, let's go to the next example quickly. So if you could just share your box and whiskers plot of life expectancy for 2016 for every country in our data set. Oh, Benjamin, it's a whisker, not a whisper. Nice, good examples. So what I want to do is go back. Okay, you're trying to be quiet. So the next thing I wanted to kind of introduce you to, let me just make this widescreen. Going back, so where we were in our little slide deck, is talking about another graphing package. And you could do everything we just did with this package. And it allows for a lot more flexibility, a lot more graphing types. So it's worth kind of exploring what's called the ggplot package. You need to make sure you have it installed. And so the package here is called ggplot2, and we use the double colon, right, to mention that this is the library and this is the function that we use. And how it works is this is just a structure for thinking about it. You pass in your data, and this is going to be your tibble, your data frame. And then you pass in what's called the AES, your aesthetics. This is going to be your X variable and your Y variable. Okay, so this is a little bit different way of doing it. So you don't have to say CEO $ salary. You can just write in salary here and age, for instance. And the data you put here would be, say, CEO. And then you add on what's called these geom types, like geometry, but geom underscore bar, geom underscore density. It's as simple as that. What I like about this is just the flexibility of the structure and the ability to kind of customize what these charts look like in a very detailed way. So let's look at some examples, and you can try these out if you have ggplot installed. So this is if you were going to do a density plot of the salary variable here. Okay, which is a basic chart, but the only thing that I did was, in terms of a custom parameter, was use this fill here so that I could choose a color to fill. Okay, but you could just see for univariate data and data graphics, we just pass in one aesthetic parameter. Okay. If we're going to do a histogram, it's the ggplot library, the double colon, ggplot, passing in our data frame, passing in since it's a still univariate display, a single variable, and then adding our geom type, which is going to be geom underscore histogram. We can add a bin width. Okay. And this will be a suggested bin width. The kind of different units here on the bottom. And then we can specify a fill color. In terms of a bar, so a bar looks much different than a histogram. This one's missing an aesthetic value. I need to fix that. So we don't want the count of age, but we actually want. Actually, no, I'm sorry. This is right. Excuse me. So we have age here, and it does the count of age. This is correct in our data set, and we have the fill parameter here. In terms of the scatter plot, we're using something called geom underscore point for a scatter plot. Okay, for our CEO data set. So I would suggest that you try these out, kind of leave you with that. We have like a minute left, but just understanding this basic structure is important. And we can even, we can do some things to even customize this further, which we'll talk about when we meet in class, like additional parameters, or you can explore those on your own for ggplot. But we can, set our labels, set our titles, and we do that with like the use of this addition operator. And we say like plus labs, and then we pass in the labels for X and Y. And we can also add a lot of different themes to customize the output of our chart. But you can see that these look kind of much more dense and rich as opposed to the ones that come from the basic graphics package. Just want to open it up now and see if you have questions. And I'm going to go ahead and stop the recording.